Good morning, class. Today we're going to do lesson number 20, and we're going to look at the future of Earth's climate. And we're going to focus to start on how we as scientists, or how scientists, make predictions about the future, and then how this relates to climate change, and then we'll talk about what we predict for the future of Earth's climate will look like. So when you make a prediction about the future, what you normally use historical precedent. So what that means in different contexts means different things, but essentially means you're going to look at data from the past up until the present, and you're going to try to model that data so that your model should match the data that already exists. And then using that model, you can make kind of fake data or simulated data about the future. So and then we can use that data to predict, okay, this is what the future is going to look like. So if every year, let's say there was 100 more people on Earth. That's definitely not, Earth's population is increasing way more than that. But let's say every year there's 100 more people on Earth. Then you can say, okay, that's been happening. Let's say that's happened for 1,000 years. We can fit that data with like a linear curve that every year we increase by 100 people. And we can predict that next year we're also going to increase by 100 people. And the year after that, we're going to increase by 100 people. So we're going to match that initial data. And the further we predict into the future, the more inaccurate we are. So the harder it is to get the prediction right. So back when humans were just evolving, or just becoming, let's say, pre-expansion into Europe, and the human population is very small. We could predict, okay, every year we're going to increase by maybe 10,000 people. And that's going to fit for a couple years. But if we said, okay, we're going to do that for the next 10,000 years. Well, right now we're increasing by probably more than 1 million people a year. So that pattern would not fit. So as things change, you want to change your predictions, change your models to match kind of the new data that's coming out. So I'll talk about that more in a second, but let's just look at, if we're trying to make predictions of the future, it's important to consider some of the factors that are going to affect what you're predicting. So for climate change, some of the factors that affect how we are, as humans, are going to react to climate change are political policies, new technology, human population, volcanic activity, deforestation, and even the sun. So if the sun warms up, which it slowly is warming up, but something we have to account for, that the sun is becoming more and more powerful. So we want to take all these factors and weigh them if they're going to be a positive or negative factor. So let's say new technology comes out and we're able to pull more CO2 out of the atmosphere than we have been before. Well, we need to account for that. So if we're trying to say, what will the CO2 levels be like in 1,000 years? Well, that's going to be quite difficult, because we got to figure out, okay, in 1,000 years, what kind of technology will we have? Will humans care about CO2 in 1,000 years? What will the volcanic activity be in 1,000 years? What will the activity of the sun be in 1,000 years? So we got to consider all these factors. So predictions up to like 100 years in the future for climate change are very hard to do, because there's so many factors that humans can change climate change so drastically. And we have in the last 100 years. So who knows how we'll do it in the next 100 years. So what scientists do is they look at the data we have on climate change and they model it. So they make a model that's going to fit the data we have right now, and then they expand that model into the future with these factors weighing, okay, do we think the CO2 levels are going to keep increasing? Do you think they're going to decrease? What is the goals of humans, and what are we lined up to? Are we lined up to meet those goals? So looking at how we model data. So if we look at the graph here, we can see that the dots, those are going to be like real data points. And this purple line is going to be model data. So we're going to try our best to fit the dotted points with a curve. So this is just going to be a mathematical equation. And then once we get to the end of the graph, the right side of the graph, that is going to be where the data stops. But we can use this model to predict what the data will look like in the future. So let's say if we extended this model to 20, we could get an accurate prediction of what this data would look like at 20 instead of just at 10. So we can do this with climate change or with anything else we're predicting that's going to help us figure out what things are going to look like in the future. So for astronomy, we do this a lot with the stars, trying to look at the life of the star. So we'll model the data, what's going on right now, and that will help us predict in the next 1,000 years, next million years, next billion years, what will happen. And because in astronomy things happen on a much slower time scale, we can predict billions of years in the future and still have accurate predictions, because there's not these different factors that are going to affect them. We can account for them easier than, let's say, like political policies. You can't really have a mathematical equation that's going to predict political policies in 1,000 or even 1,000,000 years. It's just impossible to do. But we can have mathematical equations that are going to predict the temperature of the sun in 1,000 years or 1,000,000 years or 1,000,000,000 years. So sometimes the factors you can analyze and you can accurately predict them, so you can predict further in the future. But sometimes, especially with climate change, you can't predict too far in the future without being accurate. So most of the time, about 100 years out in the future is as long as you go. We're going to look at one that goes up to 300 years in the future, but it's quite a large error range. Okay, so that is where I'm going to end for the talking about how we model data. And now let's go into talking about how this relates to climate change.